We're back with a really great follow-up to our last lesson, which was solving linear systems through all three methods. But today we're going to be setting up linear systems based on real-world problems, which is fancy talk for story problems. And I'm going to warn you, some of these problems are a little lame. So there's not a lot of creativity going on. I used a generator to come up with these problems because they work out kind of nice. And they're not very creative. All right, so this first question, we have Cody and Gabriella, and they're going to plant hostas and ornamental grass. And they bought their supplies from the same store. Cody spent $120 on 10 hostas and 10 bunches of ornamental grass. And Gabriella spent $54 on 5 hostas, 2 bunches of grass. How much would one hosta and one bunch of ornamental grass cost? So I don't know why they can't just go to the store or look at their receipt, but whatever. I'm not here to judge. So the first issue is we're going to have to kind of filter through all this information, and I like to start at the very end of the problem because the end of the problem sets up what you're supposed to find. So it says, what is the cost of one hosta and what is the cost of one bunch of grass? So right there, it sets up our variables as far as like a verbal model for our variables, and it's up to you to choose whatever variables you want. So if you're really boring like me, you're just going to use like X and Y half the time, but it wouldn't be terrible if you use something that made sense to the problem. For instance, H could represent what? Now this is where a lot of kids get this wrong. They're going to say H represents hosta, and I'm going to go, what about the hosta? The price, the number, how tall is it, how many are in a bunch. So the idea is, since the question said what is the cost of one hosta, that is what H is going to represent. It's the cost of one hosta plant. So then for the cost of one bunch of ornamental grass, any variable you want, I'm going to go with G, and that is going to represent the cost of one bunch of ornamental grass. So you have to define your variables at the beginning of the problem, that it's actually going to be a portion of your correct answer when you set them up for me. And I will tell you on this worksheet, at least for this recording, I am going to go ahead and solve this first one with you. And then for the rest of them, I'm probably just going to set them up and walk away because I'm losing my voice and I can't talk anymore. So let's filter through our information here. Let's talk about Cody. So Cody spent $120. Cool. And he got 10 hostas and he got 10 bunches of ornamental grass. So those are the 3 clues I know about Cody. And then Gabriella has 3 similar clues. So that right there tells me that Cody is going to be his own equation and Gabriella is going to be her own equation. So $120 is the total. That would make sense for me to say that that is the end of the equation. And it's going to set up like that. And then 10 hostas. But I don't know how much the hostas cost. So what if we said 10, but then we threw that variable H right next to it? Because we would multiply those together, right? And then 10 bunches of ornamental grass, but I don't know how much they cost. So what if we threw that G variable right next to that? Oops, forget your colors, Abruzzo. There we go. So Gabrielle is going to have a very similar equation. $54 total. And then 5 hostas, which again, don't know the price. All I know is that they're going to be the same price for both people. And then 2 bunches of ornamental grass. Okay, so there's my system. If all I wanted you to do was set up your system, this would be good enough. Alrighty, so we could solve this pretty easily, right guys? If I wanted to use elimination, my favorite method, I would probably look at the H's as an easy one to target. If this was a -10, I'd be in business. So what if I multiply it by a -2 to make it a -10? So this bottom equation becomes, let's see, -108 equals -10H minus 4G. So I'm not even going to look at this middle equation anymore. And then when I add up this system, I get 12. Those cancel, and then equals 6G. divide by 6, and it turns out that the cost of the ornamental grass is $2. And then I go back to the equation, my favorite one, which probably was the one I just crossed off like a dork. So then if I go back to that equation, I would write 54 equals 5 times h, which I still don't know. But then g, we just decided was 2, so 2 times 2 would be a 4. So subtracting the 4, then dividing by 5, the hostas cost $10. So we are going to write out our solution in like real world people talk. So a hosta costs $10, and the grass costs $2 per bunch. All right, there you go. So that's probably the last one that I'm actually going to go through and solve. So, all right. So this one is about Aaliyah and Eugene. They're selling wrapping paper. Customers can buy plain rolls or holiday rolls. And Aaliyah sold 2 plain and 8 holiday for a total of $184. Eugene sold 10 plain and 2 holiday for $160. Find the cost of each of 1 roll of plain and 1 roll of holiday. So that's where we're going to start with variables. P sounds good. And don't just say P equals plain paper. It is the cost of 1 roll of plain paper. I mean, you can be a little vague on your description here, but make sure that cost component is in there. And then how about H for holiday? So cost of 1 roll of holiday paper. All right, so just like in the last example, we are going to see a linear equation for each person, basically. So Aaliyah, she's going to be one equation on her own, $184 total, 2 plain, 8 holiday. So 2 plain, 8 holiday, total of 184. And then Eugene, same issue, he's going to be his own equation. So 10 plain, 2 holiday, for a total of 160. So as far as setting up, we'd be done. We defined our variables, we set up the system. I am going to have you continue on and solve this, but not this girl, guys. I'm tapping out. All right, let's take a look at number 3. Daryl and Jacob each improve their yards by planting, this time rose bushes and ornamental grass. So a very, very, very similar question to the one we just did on number 1. If you don't mind, I'm going to skip it. Like I said, I'm feeling a little parched. All right, senior class at high school A and B are planning separate trips. And I'm going to pause for a moment. I'm back. Okay. So anyways, they were renting somewhat vans, buses. Okay. So senior class A rented and filled 9 vans, 5 buses, and they fit 341 students. And high school B was 2 vans and 10 buses, 458 students. Every van had the same number of students, blah, 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 buses. Okay, find the number of students in each van and in each bus. So right there at the end tells us what our variables are going to represent. It is the number of students in a van and the number of students in a bus. So let's go with V equals number of students in one van. So it's not total students who rode in a van, just how many students fit in one van. And then how about B for number of students in one bus. All right, so when I write my linear system, each linear equation is going to have both variables in it. And I think the schools themselves are the equations. So if I look at high school A, 9 vans, 5 buses, 341 students. So 9 vans plus 5 buses equals 341 total. And then high school B was 2 vans and 10 buses for 458. Good. Again, You're going to be asked to solve this through elimination more than likely, but I'm just too tired and too sore. All right, so you tell. At school selling tickets to a spring musical. On the first day of ticket sales, they sold 3 senior tickets and 6 children's tickets for $69, and the school took in $111 on the second day, selling 7 senior tickets and 9 children's tickets. It's a poor musical. There's no one going. Anyways, the question is find the price of a senior citizen ticket and the price of a child ticket. So right there, they set up who your variables are. So I don't like to use S as variables because they look like 5s. So let's say like A is and don't just say senior citizen ticket, it is the price or cost of 1 senior citizen ticket. I love abbreviations, don't you? And then let's go C is the price or the cost of 1 child ticket. All right, so I think each day of sales is what's going to be each equation. So the first day was 3 senior citizens, 6 children's tickets. So 3 senior citizen. I chose 8 because that's what I went with. And then, oh, except I did it wrong. All right, 3 senior citizen, 6 children, total of 69. And then 111, so they kind of reversed the order, which was weird, but whatever. 7 senior citizen and 9 children for 111. Okay, so I could totally solve this if I wanted to, promise, but I'm not going to today. And Dolly and Cody, what a fun name. Oh man, I'm so sick of the hostas and geraniums problem. Oh, at least it's geranium this time. I'm gonna skip it. It's very much like number 1. Buses and vans again, huh? Oy, I can promise you we did this in class too. If you missed class and you're wondering how to catch up on your lesson, and you're like, why is she skipping all these questions? Because I'm skipping all these questions in class too. Oh, this one looks fun. Shayna and Sarah Wong are selling flower bulbs for a school fundraiser. Customers can buy bags of wildflower bulbs and a package of crocus bulbs. I don't know what that is. I don't garden. So anyways, Shayna bought this much stuff for $135. Sarah Wong bought that for that many dollars. Okay. And then what's the cost of 1 bag of wildflower bulbs and 1 package of crocus bulbs? So right there was the variable setup. So let's say W is the cost of 1 bag of wildflower. Wind. Oh my gosh, I can't read. Windflower. Need to go to bed. All right, and then C can be the cost of 1 package of crocus bulbs. I know this seems like a step that you don't feel like you should have to do, but it is really important to not just you, but also the reader to your problem, because like if you just set up a system and you don't tell me what your variables represent, I don't know what you're talking about. But I can't tell you how many times, even myself, I've done some really complicated systems where I've represented variables, things with variables, and I forgot what the variables represented like halfway through the problem. So that was a problem. And then you have to take double the time to go back and even figure out what you did. So it is worth it. It's necessary as form of communication, but it's worth it in the long run. So Shayna, she's an equation all on her own. Look at her. 3 bags of windflower. What is windflower? And then 6 packages of crocus. Are these made up? I don't know. They could be. Sarah Wong, 2 bags of windflower and 9 packages of crocus. I swear these aren't real. I'm going to Google this when I'm done. All right. And that would be the setup. Sorry for the lame problems. I mean, feel free to make your own fun ones. Short story, one day Mr. Abruzzo came home from bowling, and he knows how much I love systems of equations. And he, rather than telling me his bowling series, he set me up a 3 variable system of 3 equations so that way I could figure out what his bowling games were. He loves me.